So now we are going to discuss the fourth question. So how can we solve our fourth question? Again here also we have to find out the resistance between the terminals, this A terminal and this B terminal. Okay, so here from the single glance itself we found out that this 4, 4 and 6 are in series, this 8, 4 and 10 are in series. Okay, and we can solve this. Okay, let's find out. First, the answer is 7 ohm. We will check whether our answer is 7 or not. So we are continuing with the solving the problem. So I have already told you, you can make this as a series connection. And now here there is a star connection, the star. And okay, so other than the star, first I am taking this delta connection, 6 ohm, 6 ohm, 6 ohm, the first upper delta connection. I am taking it and I am converting it into star. So what is the question for star? That is, I am taking C, D and this point. Okay, and E, C, D, E I am taking here and I am converting it in a star connection. See here, star connection. So how can we do it? In order to find out this R1, we have to multiply these two. So 6 into 6 divided by 6 plus 6, that is 18. 6 into 6 is 36 by 18, that is 2 ohm. So R1 is 2 ohm. Similarly, R2 and R3 will also be 2 ohm because all the resistances are of equal value, 6 ohm. So I have found out R1, R2 and R3 values. Now what we have to do is we have to connect this into this older network. So I am replacing this delta connection. I am going to put from C, I am going to connect R1, then it will reach S, then R2 and then it will come into the E. Okay, and then one more branch will be there, that is R3. R3 will be connected to D. Shall we check it? See, we will check it. Okay, here look, from A there will be 4 ohm. See, from A there will be 4 ohm and it will reach C, and then when it reaches C, we have to connect this R1 to S. Okay, when it reaches C, we have R1 and we are connecting it to S. Then what we have to do? We have to connect R2 to E. So R2 is connected to E, then 8 ohm. So see here, D to E, in between D to E, sorry, in between S to E, we have R2. R2 should be connected to E, and after E there is 8 ohm. So R2 should be connected to E, then after that 8 ohm, 4 ohm, 10 ohm. Then here from S to D there is R3. From S to D there is R3. So I have redrawn R3 and 10 ohm. Okay. So I hope you understood. I have converted. Now we have all the resistance. Now I am making all the series connections, that is 6 plus 4, 10 plus 4, 14 here. Here I am replacing with the 14. Then 10 plus 2 is 12 here. So I am replacing with the 12. Then 10 plus 4, 14 plus 8 plus 2, that is 24. So I am replacing with the 24. Now I got a very simple circuit. And then how can we solve this? We can solve such that this 14 ohm and this 12 ohm and this 24 ohm. Okay, so if I check into it, this 24 and 12 ohm are parallel. So 12 into 24 divided by 12 plus 24, that value we have to get it. 12 into 24 divided by 12 plus 24, 36, and we will solve it. Then after that what we will do is the same resistance will be here also it will be there, isn't it? 4 plus 2, 6. This parallel resistance will be in series with the 6 ohm, then that will be parallel to this 14 ohm. Okay, so we have to solve like this. I repeat, this 6 plus 4 plus 14, I have drawn it here. 10 plus 2, 12 here, and 2 plus 8 plus 4 plus 10, that is 24 is replaced by a single resistance here. Now this 24 and 12 are in parallel, so 24 into 12 divided by 24 plus 12, 24 plus 12 is 36, so 12 into 24 divided by 36, that is 12 divided by 36, that is 3. 24 divided by 3 is 8. So after this parallel combination we will get the answer 8, and 8 plus this 6, 8, this parallel combination gives the answer 8, and this parallel combination 8 um, is in series first with this 4 plus 2, so 6, 8 plus 6 is 14. So after solving this entire thing we will get it as 14, and that 14 resistance is in parallel with this 14 resistance, and so 14 and 14 is 7. 14 and 14 parallel is 7, so the net answer is 7 ohm. Okay. Now we will move on to our next question, that is star delta transformation. Star delta transformation, we have to find out the current I. So from this we know this is a delta connection, isn't it? So let's check for the answer first. You got the answer as 4 by R A? Ampere, that A is for ampere. Okay, the value of current is 4 by R. Let us check. So first I am going to convert this delta to star. Okay, see this delta connection, I am converting it into star. Then how can I find out the resistance, the small resistance, that is R into R, R square divided by 3R. So what will I get? R square divided by 3R is R by 3. So this resistance will be R by 3, R by 3 and R by 3. So I can neglect this resistances in delta connection. So I am redrawing the circuit with this here R by 3, R by 3 and R by 3. So here R by 3, R by 3 and R by 3. Okay. Now this R by 3 is in series with this R. Okay. That R by 3 is in series with R. So R by 3 plus R, you will get an answer, that is R by 3 plus R is 4R by 3. And here this is R by 3 and R by 3, so this is also 4R by 3. Okay, so this is 4R by 3, this is 4R by 3, they are in parallel. So naturally 4R by 3 when comes in parallel, 4R by 6, 4R by 6, then this is in series, 4R by 6 plus R by 3, and 4R by 6 plus R by 3, that is 6R by 6, that is R itself. So here we will get R itself. Okay, then this R and R in parallel, the total resistance will be R by 2. Okay, so we have to find out the current. Current is equal to V by R, isn't it? So V is 2 divided by R. R is R by 2. So we will get it as 4 by R. Okay. Once again I repeat, in solving this entire thing, we got the answer as R by 2. We are asked to find out the current. In order to find out the current, V by R, I is equal to V by R. So V is 2. 2 divided by R by 2. This 2 will come in the numerator. So 4 by R. The answer is 4 by R. I hope you understood it. Okay. Now I am making a small modification in my question, and I am going to make the question like this. So how can we solve this? Can you please check? If I have added that star connection also inside, how can we do it? Can you please check? Please do it, and I'll upload the video in the next part.